A solution is a homogeneous mixture. It can be a solid, a liquid, or a gas. An example of a solid solution would be our alloys like brass. Air would be an example of a gaseous solution, and Kool-Aid would be an example of a liquid solution. Solutions can have a variable composition. They can be defined as concentrated or dilute, but that doesn't give us very much information. So quantitatively, we can use molarity, mass percent, or mole fraction. We've talked about molarity before, and we said that was moles of solute per liter of solution. Mass percent is the mass of our solute over the mass of the solution, and then times 100 because it's a percent. Mole fraction is the moles of what we're looking for over total moles of solution. And although it doesn't give us the concentration, we also have dilution, which is M1V1 equals M2V2. Beginning molarity times beginning volume, and that's going to be equal to our ending molarity times ending volume. So here we have a solution of 1 gram of ethanol. Ethanol is C2H5OH. It is mixed with 100 grams of water. Our final volume is 101 milliliters. Go ahead and pause the video and calculate your molarity, mass percent, and mole fraction. Restart when you have your answer. The first thing you needed to do was convert your 1 gram of ethanol to moles of ethanol. You should have gotten 0.22 moles. To calculate your molarity, we're going to divide our moles by liters of solution. We have 101 milliliters. And so 0.22 moles over 0.101 liters is 0.22 molarity. Next, to calculate our mass percent, which is the easiest, we just divide our mass of solute, which in this case is our 1 gram ethanol, over our total mass, which is 101, because that's solute and solvent. And that's 0.99% ethanol. And finally, to calculate the mole fraction of ethanol, we need moles of both our solute and solvent. We already know the moles of solute, so we need to calculate the moles of solvent, which is 5.55. And now we can calculate our mole fraction. We have moles of solute on top, and then 5.55 plus 0.022 on the bottom, giving us a mole fraction of ethanol of 0.004. We also could have found the mole fraction of water by putting 5.55 on top and still keeping the same denominator. Go ahead and pause the video and restart when you have your answer to this one. Okay, so this is also a molarity problem. So we needed to convert our grams they gave us to moles. And then molarity is equal to moles over liters. They gave us molarity and we just calculated moles. And then to solve for x, we need to multiply both sides by x and then divide by 0.014. So you should have gotten C. Go ahead and pause the video and try this one on your own. Restart when you have your answer. In this case, we have 2 molarities, 1 volume, and we're looking for the other volume, which means we're using the dilution problem or equation. We know 50 milliliters goes with 4 molar, and 8.3 goes with our unknown. Dividing both sides by 8.3, and we get that our ending volume is 24 milliliters. So we would use 24 milliliters of 8.3 molar copper 2 chloride solution and then 26 milliliters of water to have a final volume of 50 milliliters. So we've talked about concentrations, but what determines if something will actually dissolve in another substance? The first thing that determines if something will dissolve is structural effects. You may have heard the term like dissolves like. Like dissolves like will get you no points on the AP test. You have to explain what like dissolves like means. Polar and ionic solutes dissolve in polar solvents. Nonpolar solutes dissolve in nonpolar solvents. That's what like dissolves like means. So go ahead and pause the video and try answering the problem below on your own. The first thing you've got to do to answer this question fully to get full points is decide what CCl4 is, polar, nonpolar, or ionic. Then decide what water is and what bromine is. Then we can follow up with one of these blue statements above. You should have said that CCl4 is nonpolar, water is polar, and bromine is nonpolar. So always start with identifying if your substances are polar, nonpolar, or ionic. Once we've identified all the substances involved, then we can say CCl4 will dissolve in bromine because nonpolar solutes dissolve in nonpolar solvents. When two liquids mix completely, we call that miscible, like water and vinegar. Our blue and yellow drops mix, completely giving us a green solution. While when two liquids do not mix, but instead form layers, we call that immiscible, such as oil and vinegar. So which of the following molecules would be most soluble in water? Go ahead and pause the video and try to answer this one on your own. Restart when you have your answer. So again, the first thing you need to do is figure out if they're polar or nonpolar. CCl4 is nonpolar. CH3NH2 is polar. HI is polar. And CH4 is nonpolar. So we can eliminate A and D because water is also polar. So now we have to decide out of B and C which one would be most soluble in water. Water can form hydrogen bonds, and so we need to look and see which one of these can form hydrogen bonds as well. HI has hydrogen, as does this one, but there's no nitrogen, oxygen, or fluorine. While here we have nitrogen attached to hydrogen. So it can also hydrogen bond, and that is our answer. So C would also dissolve, but not as well as B. Go ahead and pause the video and figure out what magnesium chloride would look like after it's been dissolved. So here in the picture we have solid magnesium chloride and we have water molecules before it dissolves. Magnesium chloride is ionic, so when it breaks apart, it should break apart into magnesium ions and chlorine ions. And then water should surround it to form hydration shells. So magnesium's +2 should be around oxygen's -2. And so something to this effect. So notice magnesium's positive charge is attracting oxygen's negative end, which is oxygen. And chlorine, being negative, is going to attract water's positive side, which is hydrogen. Pressure can also affect how much will dissolve, but only for gases. Because gas particles are so far apart from each other, if we increase the pressure, they'll get closer and more of them will go into solution. This is what we call Henry's law. If you increase the pressure, you're going to increase solubility. You know this from when you go to the grocery store and get a Coke. It's bottled under all that pressure. Whenever you open it up, then it releases a lot of that CO2 because the pressure has gone down and not as much CO2 will stay dissolved. Temperature will also affect the solubility. For gases, when you increase the temperature, you decrease the solubility because the molecules are going to be moving faster and they're able to come out of solution. Again, think of soda. Whenever you increase the temperature in a sealed can, it's going to explode. Or if you heat a Coke up, then it's going to become flatter faster. For solids and liquids, solubility have a direct relationship. Increase the temperature and you increase the solubility. So here we have a solubility graph. You should be able to read one of these. On the x-axis, we have temperature, and on the y-axis, we have solubility. How many grams will dissolve for every 100 grams of water in this case? So we could find a temperature at 20 degrees. We could have a little over 200 grams of sugar dissolved in 100 grams of water. There are two substances in red that are actually decreasing in solubility with an increase in temperature. Those substances must be dissolving endothermically, while the other ones are dissolving exothermically. Here's a solubility graph for gases. Notice that they all go down when you increase the temperature. Go ahead and distinguish between saturated, unsaturated, and supersaturated solutions. A saturated solution contains the maximum amount of solute that can be dissolved at a given temperature. Unsaturated, less than the maximum amount of solute has dissolved. In other words, more can dissolve. And supersaturated, more than the maximum amount of solute is dissolved at that given temperature. Supersaturated solutions are unstable. In terms of the graph, if I dissolved about 240 grams of sugar at 40 degrees Celsius, that would be a saturated solution. If I dissolved 180 grams at 40 degrees Celsius, that would be an unsaturated solution. And if I heated it up and dissolved, let's say 260 grams, and then I cooled it slowly and I still had all 260 grams, that would be a supersaturated solution. That's how they make rock candy. Go ahead and pause the video and try this one on your own. So increasing the pressure of a gas should increase the solubility. If that said a solid or a liquid, then it would have had no effect. Go ahead and read the problem and try this one on your own, restarting when you have your answer. So in this problem, we have 29.3 grams dissolved in 100 grams of water, and now we only have 87.9 grams of water. You should set up a proportion to solve for x. Solving for x, you get 25.8 grams, or D.